I wanted to take you over to Desmos to kind of talk to you about the parent functions and what they might look like in comparison to other functions that are in the same family but not necessarily the parent. So here I have for you a red function, y equals x. So this function is a straight line, so this is going to be our linear function. Now notice how in this function I have y equals x. There's no extra numbers, no extra things in there, no negative signs, nothing crazy. So this is the most basic function that you can have for a linear function. Well, why is it considered linear? Well, we talked about the definition being that it is a first degree polynomial or first degree function, which means the highest exponent here is 1. So if you notice, if I type in y equals x to the power of 1, these are the exact same function. Why? Because the highest exponent is 1. Well, how do we know it's 1? Well, remember in math we have those imaginary things that are there, but we don't actually see them, or it's like invisible, not really imaginary, but it's invisible, right? So we have this invisible exponent of a 1. So it does have an exponent of 1. The highest exponent is a 1, which makes it a single first degree, and also makes it a linear function. Now this is the parent function, which means that's the most basic line that you could possibly create. Now once I start adding in some letters, so maybe like y equals 3x, let me go ahead and change that color. Once I have y equals 3x, that's when I notice, oh my gosh, hey, this is when I have a different line that is different from the parent, but it's still a line. So if I look at this function just by itself, this is still a line. Let's go ahead and we can change it up a little bit too. We can have y equals -2. Just y equals -2. Why not? So we have a flat horizontal line here. It is still a line, and you'll notice the highest exponent here is technically also a 1, because again, if I raise this to the power of 1, it doesn't change my function in any way. And then lastly, I'll give you one more example. Y equals -4x minus, let's do +2, for example. This is also a straight line, a linear function, because obviously it makes a line, but it's also a first degree. The highest exponent in this function is also 1. Again, if I raise this to the power of 1, it doesn't change the fact that it is still a line. And if you look at all of these are all lines. All of these functions are lines, but only one of them is the parent, and they all stem from the parent. They're all in the same family, they're all lines, but the red line, the y equals x, is the parent here because all of the other ones derive from this line. Now let's talk about quadratics for a second. So we talked about how quadratic functions, the highest exponent here is going to be a 2. We talked about it's a second degree polynomial or second degree function, which is the highest exponent you see as a 2. Well, obviously with y equals x, the highest exponent here is a 1. So to keep it basic, because parent functions have to be basic, the most minimal thing I can do to this is just add an exponent of a 2 on it and makes a quadratic. This is also known as a parabola. It's also a parabolic shape, however you want to say it, but this is a parabola. It makes a shape of a U. If I get rid of that squared though, it's going to be like a line again. So again, if I put a square on it, it makes a parabola. If I get rid of it, it's a single first degree, so it's a linear function. And then if I add the square there, obviously it makes a quadratic here. So there's different types of different quadratic functions as well. So this is the parent, the most basic quadratic you can make, because all you need is a y and an x, input and an output, and then you square it and it makes a quadratic. So that 2 being there forces it to become a parabola. If that 2 wasn't there, then it would just become a line. So that is necessary, and it's the most minimally invasive thing, so we are allowed to put it in, but we can't add anything else and call it the parent. So I'll go ahead and give you another quadratic. So y equals 4x squared. Again, also a quadratic, different from the original, right? Because look, if you look at the red one, it's a little bit wider, and the new one's a little bit more narrow. But I could add some more stuff, plus 3x minus 2, for example. So how do I know this is still a quadratic? Well, one, we can see the graph, but what if we couldn't see the graph? If you look at the equation itself, the highest exponent we have here is a 2. And because the highest exponent here is a 2, we know that this is a quadratic. So what happens if I get rid of this 2 and I get rid of that exponent? What does it become? Well, now it's just a line again, because we got rid of that squared, we got rid of that exponent of a 2, so now this is just a first degree function, which makes it a line. So that squared is necessary, that exponent of a 2 is necessary in order for this to be a quadratic. And then I can go ahead and create some that are face down, so like 3 minus 5x squared, for example. This will open upside down. It's still a quadratic, but it's opening downwards. So if you notice, all of these are quadratics. They all make a U shape. They all are in the shape of a parabola. However, the parent function, which is the red function, is the original parent, the most basic of all of them. And then lastly, we have the exponent, or the exponential parent function, which is y equals 2 to the power of x. So it looks like this. Again, we kind of talked about how it kind of starts off flat on this left side and it goes up really high. Now the exponential parent function is actually really unique, because if you look, it looks like it's like right on top of the x-axis right here. So this is the origin, this is 0, 0, and it looks like it lays right on top of the x-axis. But if I zoom in and I look, and I keep zooming in, here we go, it's almost there, I think. If I keep zooming in, I'll notice, oh, sorry, I need to glitch out because I'm too close to that side, so I'm gonna go ahead and keep doing this. Okay, sorry, keep zooming in. You'll notice, finally, that it doesn't actually touch the x-axis. So the unique property about this is that it gets really, really close to the x-axis, but it's never actually going to cross. We can talk about this a little bit more in Unit 8 when we talk about what that line, that boundary is called, but for now, we're just gonna note that, hey, this is something unique about this function. Now, this is our most basic parent function, so I can add some more stuff to this to make it different for the parent function, for the exponential parent function. Now, the exponential parent function still includes a y and an x. It has an input and an output as well. So just to remind you, the linear parent function is y equals x, and then we have y equals x squared. So all of these have a y and an x, if you notice. Y equals x being the most basic with no letters attached, first degree, that's going to be a linear. Add that exponent of a 2, now it's a quadratic, that purple one. And then, say that purple one right there. And then that blue one is now the exponential because the exponent here is an x. So we talked about how the exponential parent function, your variable is in the exponent. So we're not going to have a number up there in the exponent when we have just the basic function. We can plug stuff into it later on, but it's just y equals 2 to the power of x. So I can go ahead and create other exponential functions. So maybe y equals 3 to the power of x minus 2. So this is also an exponential function. You notice how it's kind of flat and it goes up really, really high like that. This is also an exponential because the exponent is a variable. It's an x. If I do y equals, let's see, 1/2. Is it 1/2? Let me try maybe negative 2 to the power of the power of x or something like that. So again, also exponential. I haven't really talked to you about this one yet, but this one is also exponential because it's kind of going down. It's flat over here and then it goes downward. They talk a little bit more about that in later math classes later on, but this is also considered exponential, and it's a still part of the exponential family. It's just not the parent function, even though it might look similar to the blue function. But notice the red is an inverse. It's actually the opposite way. So it's not the parent because it's been changed in a way. And then lastly, we'll go do maybe, I'm trying to think, what can I do here? Let's see, 1/2. There we go. Okay, and then this one right here, this is also exponential because, again, your exponent is an x. Sorry, I was trying to make up examples, and that's the first thing I thought of. And so it starts off high up in here on the left side, and as it goes down to the right, it's getting flat on the right side. So it's kind of the opposite of what's happening over here on this one. So just to let you know, there are different types of exponential functions as well, but they're all exponential. They're all in the same family. It's just that there's only one parent. So just to remind you, your parent function for a line is y equals x. Your parent function for a quadratic is y equals x squared. And your exponential parent function is y equals 2 to the power of x here. So those are your three parents. They're all different. Remember, green's a linear, so it's going to be a straight line. Purple is a parabola. It's a quadratic, x squared. And then your 2 to the power of x is an exponential, which is kind of flat, and then it grows rapidly fast.